So here we go, guys. Notes 35. Let's go ahead and get started. Um, we're going to find area of regions, area of regions, regions of area. We're going to look at regions and we're going to calculate the area. So here we go. We already know this part, but I think for the most part, this equation up here, that's the square root of x. This equation with the linear line, that is y equals x minus 2. And they tell me that right here and right there. And the region that they want is that shaded region of A and B. And they're being nice. Maybe I should have deleted this because that's what we're going to write right now. But we're going to go ahead and calculate that. So I want to find the area of region A. I know that the total area is region A plus region B. And I guess I should say region, the word region, right? So the way to do that, guys, the way to find the area of region A is just to do integral. Notice these are all dx's. When I say what they're all dx's, I'm talking about like the rectangles that you would have in here. The rectangles are all like that. So they're all the d. You're going to add up an infinite amount of rectangles. So with respect to the x-axis here, they're all the dx's here. So that's what I mean when I say with respect to x there. So here we go. I'm going to integrate from 0 to 2 of just this curve. And that curve is square root of x. And I'm going to add, let's see, what am I going to add? Because I want to add region B here. The area under this curve. Now look, if I have rectangles right here, here's how my rectangle would look like. So how do we say, what do we say that we, how do we add these, or how do I find that area? We do upper minus lower curve. To help you out, which one's upper, which one's lower, I just do a little line and pretend that's like a rectangle there, like a dx there. And you can tell which one's upper, it's a square root curve. And which one's lower, the lower is the x minus 2 curve. And from what to what? From 2 to 4. Put a dx. There it is. Let's make it look a little prettier. So on the side, I'm going to go square root of x minus 2, distribute, square root of x minus x plus 2. So that's what I'm going to make. That's what I'm going to do, guys. I'm going to write it like this, guys. Integral 0 to 2, square root of x dx, plus integral 2 to 4, square root of x minus x plus 2 dx. Let's see if we can do this. Let me take a sip of my coffee real quick. It gives me energy. Antiderivative. Remember that the square root of x is x to the half. So I'm going to add 1 and divide by that. So x to the 3/2 divided by 3/2. That's the same thing as multiplying by 2/3. I put this in a little bracket. I put 0 to 2 because I got other terms that are going to be coming in. Plus, I open up a bracket. Let's see. Antiderivative of the square root of x. We already said that's 2/3. So I'm going to write 2/3 x to the 3/2. Let's see if I can fit it in here, guys. Let's see. Minus antiderivative of x is x squared over 2. You can say half x squared if you want. Plus antiderivative of 2 is 2x. I close my 3 terms that I'm adding up. I put a lower limit of 2 in the bottom, an upper limit of 4 in the top. Let's try to do as much as we can without a calculator, guys. Let's try. So let's see if we can do this without a calculator. So the first term here, let's see, that one's going to be pretty simple. So I can just go ahead and just parenthesis 2/3. Let's see, 2 to the 3rd power is 8. You know what? I'm not even going to bother. 2 to the 3/2. There's a reason why I'm not going to bother, and you'll see right now. Plus, and I'm going to put my little bracket. I'm going to do upper minus lower. Now, don't worry. 2/3, and I guess giant parenthesis here on the outside. I'm going to color code it in green there. 2/3, 4 to the 3/2, and we'll simplify it in a little bit, minus 4 squared over 2 plus 2 times 4, close and close, that's my green one, minus, and here comes the green one again, green, and then I'm doing the lower here, 2/3, let me write the 2/3 better, 2/3, 2 to the 3/2, oh look at that, I see something happening there, minus 2 squared over 2 plus 2 times 2, and then let me close the green one and close my bracket. Ooh, that was tough. We haven't simplified anything, relax. If I were to distribute this negative, look at this. This guy turns negative, this guy turns positive, and this guy turns negative. Do you guys see that? And there's a plus symbol on the outside. So that means I can just drop the parentheses and put minus, plus, minus, and I can actually drop the bracket as well. So what does all that mean? Well, look at this. I have 2/3, 2 to the 3/2, positive. I'm going to put here a black dot here. And I have 2/3, 2 to the 3/2, but negative. I'm going to put a black dot there. What's going to happen to those two terms? Yeah, that was cool. They cancel out, guys. So now life is easy again. Let's see how easy it is. So here we go. I'm going to start with the 2/3, 4 to the 3/2. You can do whichever one you like first. If you think 4 to the 3rd power is easier and then take the square root of that, go ahead. The 4 to the 3rd power is 64. The square root of 64 is 8. That was actually not that bad, actually. I actually think it's easier to do a square root and then raise it to the 3rd power. The square root of 4 is 2, and then 2 to the 3rd power, 8. So I have 2/3 times 8 minus 4 squared is 16. 16 divided by 2 is 8 plus 8. And look, I already have this plus symbol over here. Plus 2 squared is 4. 4 divided by 2, 2. And then 2 times 2 is 4. So minus 4. There it is, all of them. So now let's see, guys. Equals 16 over 3. I see the 8 canceling out. 2 minus 4, I see minus 2. So 16 over 3 minus, and then I'm just doing common denominator. 2 times 3 is 6, so minus 6 over 3. 16 minus 6 is 10, so 10 over 3. Man, that was a lot of work just for that one little number. And there it is, guys, 10 over 3. How do we feel? Okay. There it is. We're done. So let's go to the next page. Chavez, did you do a mistake? It looks like it's the same question. Nah, it's by design. I did it that way on purpose. Look what it says. Find the area of the region in example 1 by subtracting the area of the triangular region from the area under the square root curve. Chavez, I have no idea what you're talking about. Here's the square root curve. I want you to notice. Do you see that in green? Isn't that just a triangle? So can't I just find the area under the curve of the square root curve, which would give me everything here in red? And if I subtract the region in green, won't that give me the same answer then? It should. It should technically, right? So let me see if I can color code this. Area in red, so I'm going to write total area. I guess I should write total area as the neutral color. So total area equals, and then whatever's in red is from the shaded region in red, 0 all the way to 4 of the square root of x dx. And I'm going to subtract, so I'm going to neutral color, minus, and I'm going to subtract the area of the triangle. So I'm going to put that in green here. Area of triangular region. Triangular region in green. So there it is, color-coded. Nice and pretty. I'm going to see if I can stay consistent with my colors. So here we go. So I'm going to put equal sign because I'm doing total area of the A and B, right? So total area of A plus B, the region of A plus B here. So here we go. Antiderivative of x to the fourth, we just said that was 2/3 x to the 3/2, and I'm going to evaluate this from 0 to 4. And I'm going to subtract the area of that triangle. So I come over here and I'm like, okay, area of triangle, let's figure it out. Area of triangle equals, let's see, the base here is 2, because the difference between 4 and 2 is 2. The height is 2. So area of triangle is 1/2 base times height. So it looks like my area is just 2. So I'm going to subtract 2. And I'm trying to go slow, guys. Equals, so let's see. I'm going to plug in a 4. So I'm going to write 2/3, and it's 4 to the 3/2 here. And I don't have to worry about the 0, because 0 to anything is 0. And I'm just going to subtract the 2 there, minus, and then keep it with the theme 2 equals. Let's see if we can figure this out. Now I'm just going to write everything in black. The square root of 4 is 2. 2 to the third power is 8. 8 times 2 is 16. So 16 over 3. Minus, and that 2 times 3. So that's the same thing as 6 over 3. And I'm getting a message that my internet is unstable. So I'm sorry if it's freezing here. And then 16 minus 6. Oh, look at that. 10 over 3. We got the same answer, guys. Happy face. I thought that was pretty cool. I hope you guys think it's pretty cool too. All right. Well, there's another method, as you guys can see. You can also find area. All these, okay, what have we been doing? All of these questions so far, notice that I have been integrating with respect to x. You guys notice that? Like, they're all my rectangles, all my Riemann sums, they're all dx's. But what if they're not? What if my rectangle looked like this? So let me see if I can write some notes here. Don't worry, we're not going to go back to the summation. I mean, we can if we want to. So notice this time your dy, that distance there, that's a dy, the difference in y's. Now remember, the area of a rectangle is length times height, or width times height, right? So there's my dy, I got to find my height. So to find your height, so I'm going to use this one as an example. You always go right to left on this sum. That's how you tell which curve is on top. Chavez, but why? Well, let's pretend that this number here was a 2 and that this number way back here was a -3. If I told you I want to know what is the length of that rectangle, I would hope that you would tell me 5. And you got 5 because you know that the difference between 2 and -3 is 5. 2 minus a -3 is 5. If you go left to right, you would have told me -5. But I don't want negatives, I want positives. So how do you tell what curve is on top when you're doing it with respect to y's, when you're doing dy's? Right to left. The curve that you hit first from right to left is the one that is quote unquote on top. So I'm going to go ahead and write quote unquote, this is considered top. And this curve down here, quote unquote, is considered bottom. Just like we were doing with dx's. Does that make sense to you guys? Goodiness, does that make sense? Okay. All right. I want you guys to notice the lower limit is c. Notice that we're, look, that's your lower limit up there. And at the upper limit is d. I want you guys to notice that. Why? Because we're not integrating with respect to x. We are integrating with respect to y. So if we're integrating with respect to y, that means that I want to have everything inside in terms of y, not the variable x. Does that make sense? Okay, we're going to do some examples. You guessed it. We're going to do that same problem that we've been doing. I should have put the picture in there. My bad. I'll put the picture in right now. Find the area of the region, example 1, by integrating with respect to y. Okay, so let me draw the region first. Square root of x. That's the square root of x. And here is And there is the linear line y equals x minus 2. It was given in the problem. This value is a 2. This value over there is a 4 comma 2. So I know that's the origin, and that's a 2. What am I trying to find? I'm trying to find this region right there. Okay, right to left, I can see that it's a linear line minus the curve, minus the square root curve. I need to write these in terms of x equals because I'm going to integrate with respect to y. So I always like to do these little segments here, guys. Notice I did a straight line here in black. So I always pretend that's like my rectangle, and I'm like, oh, that's a dy. So anytime you see me do this, I'm saying they're dy's. Like I'm saying the difference in my rectangle, that's a dy section. dy, 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 dy. Travis, what's a dy? In my head, I do this. I'm pretending like I have a rectangle right here, and this right here specifically, that right there is a change in y. So I say that is like a dy because we're talking about calculus. Does that make sense to you guys? Okay. Whenever you see me do a rectangle or whenever you see me do something like this blue line, I just do a horizontal. I'm saying that's like a dx. Yes, ask. Oh, because now I'm integrating with respect to y. My rectangles are no longer tall rectangles. Now I have rectangles like that. You know what I mean? Okay. We want in terms of y, because we're doing width times height, but the dy's, everything's in terms of y. So we need everything in terms of the variable y. All right, here we go, guys. Y equals square root of x and y equals x minus 2. I want these to say x equals, not y equals. They're the same curve. So first, I'm going to call this curve 1 and curve 2. So here we go. For curve 1, you just square both sides. X equals y squared. It's the same curve, guys. It's the same curve. For curve 2, move the 2. X equals y plus 2. Are we okay? These are the same curves, guys. If our calculator said x equals instead of y equals, we would type that in. X equals y squared, and it would graph the square root curve, the y equals square root of x. It would actually graph this. It would graph this, where this part is y equals the square root of x, and then the bottom one is y equals the negative square root of x. We'll talk about that later because that problem is coming up next. Okay, sorry guys. I wanted to give you that info there. Okay, here we go. Right to left. I'm going to integrate from, well, I guess we'll choose these limits in a little bit. The first curve that comes in, remember we're going right to left, is a linear line. The linear line is y plus 2. And I'm going to be subtracting the y squared dy. My lower limit, I don't think anyone's confused on this one. The lower limit is definitely 0. But what is my upper limit? Is it 4? Is it 2? Which one is it? 4 or 2? It's 2. Because we're integrating with respect to y. What was the question? Someone had a question. Diakana?
No, I said it's 2.
Oh, thank you.
Your question.
Yeah. You're a boss. You got it right. If you want to rewrite it, I always like to rewrite it, guys, because I like to have the highest exponent first. But if you don't want to rewrite it, that's okay. You can leave it alone. So here we go. I'm going to go ahead and leave it alone because we're rookies right now. So I'm going to write y plus 2 minus y squared. If you want to put parentheses, you can. If you do not want to put parentheses, you don't have to. Antiderivative. Antiderivative of y. Y squared over 2. Antiderivative of 2. 2y. Antiderivative of y squared. Y cubed over 3. Put all these in brackets. I got 3 terms there. 0 to 2. I'm just doing upper minus lower. What's up? Oh, okay. I don't want you to think as bottom. Okay, so the question was, we did top to bottom, right to left. Remember why we did top to left? Because we're trying to get a positive value, right? To get the area of that rectangle. Now, the reason why it seems unnatural to you guys, you're like, hey, but you did bottom to top, not top to bottom. On the number line Y, the more you go up, the numbers start getting bigger, 0 to 5. And the number Y on the number line Y, if you go down, those numbers are technically smaller. We're doing the same thing when we integrate with respect to X, left to right, quote unquote, or right to top, bottom, but then the lower limit is the leftmost, and then the upper limit is the rightmost. So it's the same. The lower limit is the bottommost, and the upper limit is the topmost. Do you see that? Okay. Here we go, guys. 2 squared is 4. 4 divided by 2 is 2. 2 times 2 is 4. So all right, plus 4. Minus 2 to the third power is 8. So 8 over 3. And I don't have to worry about the 0 because anything to 0 is 0. So let's see if this is true. 6 minus 8 over 3. 6 times 3, that's 18. 18 over 3 minus 8 over 3. And look at that. We got the same thing again. Isn't that awesome, guys? I think it's awesome that you can do the same problem 3 different ways and get the same answer. So there it is. I hope that we feel like we're getting better. All right, take out your calculators. You're gonna need them. So if you don't have a calculator, go get your calculator. We'll give you guys time now. I got my calculator right here. And I will use it in a little bit. I don't have a name for my calculators. Like I have several calculators, but you know what? I'm gonna start naming them. Okay, it says find the area of the region enclosed by the graph of y equals x cubed and x equals y squared minus 2. This curve right here, that is x equals y squared minus 2. But you can't type that into the TI-84. So that's why they told you y2 and y3. So I'm going to first find this with respect to x. With respect to x. So here it is. I'm drawing dx's. So I notice right there, I need to figure out that letter, that point there. It looks like it's -1, -1. I think it is. And then I see top to bottom, I see that after I pass x equals a, it's always the square root curve minus the x cubed curve. Do you guys see that as well? Okay, so here we go. Don't worry, I'm gonna go slow. I'm gonna type in y1 equals x cubed, and then y2 and y3, I'm gonna type in those expressions. Where did they get them? Relax. Here's what they got them from, guys. X equals y squared minus 2. If you move the 2 to the other side, I'm gonna go ahead and rewrite this. I'm gonna write y squared first. Y squared equals x minus 2, square root, y equals plus minus square root of x minus 2. The top one here is a positive 1, and then the bottom one here is the -1. And then that's a skill that we should have learned in algebra, specifically algebra 2 course. These are hopefully not too hard for you guys. So here we go. I'm gonna bring up my calculator and you guys are gonna follow along. Hopefully do the same thing that I'm doing, share screen, that one. So can you guys see my calculator? Okay, here we go. I'm gonna turn it on. And I'm gonna go to y equals, and I'm gonna type in on y1 x cubed, so x to the third power. And on y2, I'm gonna type in the square root. Don't worry about that. I was working on this handout earlier. Square root of x plus 2. Oh, wait. Why did I? Okay, there's a small error there. Do you guys see the error? This should be plus, guys. That should be plus. Let me bring back my calculator. All right, square root of x plus 2. And then on y3, I'm going to put negative square root of x plus 2. And don't push graph yet. I'm going to change my window to that window right there. Window, -3 to 3 on the x min, x max, x scale by 1, that's fine. Y min, -3 to 3. And I push graph. Okay, we're going to practice finding intersections, guys. You tell the calculator to find the intersections for you. I already know definitely that AB is definitely -1, -1. Because look at it. -1 to the third power is -1. -1 squared minus 2. -1 squared is 1. 1 minus 2 is -1. So that is definitely -1, -1. But let's practice. Second, calculate and look for a button that says intersect. Number 5 on mine. I think it should be the same on yours. And it says first curve. Well, I'm going to move this cursor to the left. I'm in the x cube. Yes. Y1 is x cube. Enter. Second curve. Nope. I don't want the positive one. I want the negative one. So I just push on the arrow key. There I am. I'm on the negative one. I push enter. Guess. Well, there's only one intersection, so you don't have to worry about that. Push enter again. Bam. -1, -1. Sometimes the calculator does something funky and it'll say -0.9999999999999. It's -1. So we're good on that one. We don't have to worry about that. That is definitely -1, -1. Let's go find C and D, guys. So here we go. Second, calculate. Number 5. And then it says first curve. Well, nope. There it is. Push up and down. I want that curve. Enter. Second curve, I want the x cube curve. No, not that one. Not that one again. There it is. Second curve, x cubed. Enter. Guess. Well, there's only one intersection, so you can just push enter again. And boom, there it is. Here's what I get. I'm gonna write it over here. I lost it. Can you tell me what it is, Godinez? So I got 1.2148, comma 1.7930. Okay, I'm gonna show you guys how to store it to use the exact. So here we go. Can you guys see my calculator? Right now, at the moment, it is stored in register X and register Y. So go to your home screen. Second, quit. If you type the letter X and you push enter, it should be that same number. I'm going to store it, and I'm going to use their logic. They stored it in letter C, so I'm going to store it in alpha C. I push enter. I want the Y1 too because I'm going to use it later on. Not right now, but I'm going to use it later on. So the Y1, how do I get the Y1? Look for the letter Y, so push alpha Y, so it's in number 1. Alpha number 1, push enter, and look, there it is. Store it. Don't store it in Y, store it in I'm going to use the letter D. There it is. Now, you want to make sure, you want to get full credit, guys. So what I'm going to do, I'm going to put 1.2148, and I'm going to go letter C, and I'm going to write 1.7930 and letter D. What I'm telling the reader is that I'm storing those numbers to those letters. Cool? Next, here we go. Finally, we're ready to find the area of this. So I want to find this area. What area am I finding? I'm finding all that area right there. Yes. Oh, they told me the enclosed region. And the one on the right is not enclosed because it goes forever like that. You know what I mean? Okay, here we go, guys. I'm finding my area. Don't worry about that. Integral from x value -2 to x value -1. You have to do it in 2 regions, guys. And the top curve is the square root curve, square root x plus 2, but the positive one, minus the bottom curve is a negative square root curve, dx plus integral from -1 to the letter C. The top curve is the square root curve, square root of x plus 2. And the bottom curve is the x cubed. If you want to put giant parentheses like that, you can. All right, how do I type it into the calculator? Let's see, this one was in, what was that, y2? That was y2, this was y3, this was y2, and this one was y1. That's exactly how I'm going to type it in. So let me take out my calculator. Can you guys see it? Where can I write? Okay, right here. All right, here we go. Math, number 9, and mine is number 9. I don't know what it is on yours. -2 to -1. Guys, you got to practice with your calculator, guys. Move to the right, and I'm going to type it in. Alpha, trace, and I'm going to call it y2, so that's where I have it, minus alpha trace y3. And then I'm going to move the cursor, put an X there, push plus, and here we go. Math 9, -1, all the way to alpha C, because I already stored it in C. And I'm going to type in y2, alpha trace y2. And x cubed is simple enough. You can write x cubed if you want, but I'm gonna type y1, alpha trace y1. Put an X, and I push enter. There it is. I got 4.2149. It should be accurate to at least 4 there. 4.2149. Are you guys ready to do this with respect to y? Trying to do an accent, but I'm not doing a good job. It's going to be a lot simpler, guys.
We have a question.
Yeah, ask.
Why did we have to split it up between -2, -1, and then to -1 to C?
Because I have a different equation after I pass -1. Look at your dx. Your dx right here is between this curve and this curve. The top one is a positive square root, the bottom one is a negative square root. After I pass -1, it's a different curve. It's the x cubed curve.
Okay.
Do you see it?
Yes.
Yeah, that adds it up. Yeah, I know what you mean. All right, guys, let's try it with respect to y now. See if it makes the life easier. With respect to y. It does make life easier because notice with respect to y, so this is what I'm talking about when I say dy's. Notice with respect to y, it's always the same curve, the same two curves all the time. Do you guys notice that? The curve on the right-hand side is the one that's always on top if you do it with respect to y, and this curve is always in the bottom. Always, always, always. So it becomes a lot easier to do it with respect to y on this one. So let's see, what curve is on top? The x cubed. So what do I need? I need to turn everything in terms of x equals. So y equals x cubed, arrow. That means that x equals the cube root of y. You could also say that's y to the 1/3. It does not matter. Just be consistent. And then we already know that this bottom curve is x equals y squared minus 2. X equals y squared minus 2. So here we go. We're ready now, guys. Integral from, again, the y value there is -1. The up value, we're not using letter C, we're using what letter? D. Hopefully you already have it stored in your calculator. And then the very first curve, that's the x cubed curve. So I'm going to write it as the cube root of y. The cube root of y minus, parenthesis, y squared minus 2 dy. I'm just going to type it out, guys. So here we go. Let me rewrite it. I'm going to distribute this negative here. Integral from -1 to d. I'm going to write it as y to the 1/3 minus y squared plus 2 dy. All right, I'm gonna take out my calculator. Where's my calculator? Boom. All right, here we go. I would just stick with the letter X. It's a dummy variable, guys. When you're typing into the if it bothers you, go ahead and use the Y. It doesn't matter. I'm not going to bother using Y1, Y2, Y3 anymore. I'm just going to push math 9, -1 to alpha D. I think I stored it in here. We'll see if we get the same answer. And I'm just going to type this in. X to the 1/3. If you want to use the letter Y, go ahead. It's just that I want to push left buttons. Minus X squared. Oh, I didn't put a minus in. Minus X squared. And then delete this part. Delete. Oh man. Delete. Plus 2. Let's see if we get the same thing with respect to X. Enter. It's working. It's working really hard. And there it is, guys. 4.2149. 4.2149. I want you guys to notice something. I want you guys to notice after that 9, it's different. The areas are actually exactly the same. The calculator is limited. For those of you that are computer programmers, Mazuka probably has a better idea about this. It's using an algorithm, guys. And it's using an algorithm with respect to like accuracy or I'm not sure about the tolerance. It depends on the tolerances. And the software that it's using, it's running a process. And once it reaches a certain tolerance, it stops executing. And it really is adding an infinite amount or trying to. It's trying to add an infinite amount of rectangles. The calculator is. Does that make sense? And then once it gets towards a certain amount of accuracy, it stops executing. So there it is. That's about as strong as it can get. 4.2149 is pretty safe. That's why the AP exam they say to the 3 decimal places, because certain calculators will give you different numbers. But there it is, guys. It's safe. The calculator worked really hard for that. So thank you, calculator, for working really hard. And we got a pretty good answer. Maybe not the exact answer, but pretty good. All right. Any questions so far? Yeah, kind of. Were you about to say something and I cut you off by accident?
No, sorry, I was talking to my sister.
Okay, we're good, man. All right. So I want you to know that the calculators are limited, guys. The harder the curve, like the fancier the curve is, the harder the calculator is going to start working. So I want you guys to know that. So the calculators are limited. It's just a machine. It's just a machine. All right. Last example. Oh no, we got 2 more. Don't worry, but they're easy. These are easy, guys. We don't have to do anything by hand. We're just going to do it by calculator. So notice this one says the shaded region shown below bounded by the functions blah and blah, and the y-axis and the line x equals 1.5. Find the area of the shaded region using a calculator. Round to the nearest thousandths. Okay, so here we go. This looks like a perfect 1,5. I would verify that. Let's see. -4 plus 9, definitely 5. Yep. And let's see, 1, -2 plus 7, definitely 5. Yep. -1,5 is an intersection point. If you want to put those in your calculator, go ahead. As a matter of fact, we are, because we're going to use a calculator. Y1, Y2. So here we go. I'm going to take my calculator out. Let me move it to the right-hand side here. And I'm going to go to Y equals. I'm going to clear what I had. Clear, clear, clear. And I'm just going to type in Y1, -4x squared. So everyone try this out, guys. If you have a calculator, try it out. As you can see, we're not using Desmos because I want you guys to get used to the calculator there. And -2x plus 7. So there it is. I have it in my calculator. I'm going to go to the home screen. So how do I do this? Well, notice between 0 and 1, what curve is on top? The parabola or the linear line? Yeah, the parabola. So I'm going to write math 9, and I'm going to go from 0 to 1. And the parabola, I wrote my little notes here. I have the parabola saved in Y1, so I'm going to go alpha, trace, Y1. minus, and then I have the linear line saved as y2, so I'm just going to go alpha trace y2. Don't push enter yet. I want to add this region, the second region here. Push plus. Now, which one's on top? After I pass x equals 1, this time the order changes. Which one's on top now? The linear line, right? So I'm going to go math 9 again, and I'm going to go from 1 to 1.5. And this time I'm going to write y2, because that's where I have my linear line, alpha trace y2, minus, and then the parabola, alpha trace y1. And then I go with respect to x, and I push enter. And there it is, guys. If it says 3, 3, 3, 3, 3, that's a good indication this one's probably a perfect area. 2.58, 3, 3, 3, 3, 3. 2.583. If this were an AP exam, I would not write y1 and y2 because they're already telling you what the letter is. If this were an AP exam, guys, I would go 0 to 1, and then I would go f of x minus g of x dx plus 1 to 1.5 g of x minus f of x dx. Does that make sense, guys? And there it is. And there it is, guys. You're done. All right. Let's go to the last one. Let the shaded region be the area enclosed by the function f of x equals square root of x minus 2, the horizontal line y equals 0, and the y-axis. Write an integral in terms of x and also an integral in terms of y that would represent the area of the shaded region. Love it. I love it. Oh, my heart didn't come out very good. Okay, you know what? Whatever. All right. Here we go. I know some of you are tempted. I've seen this done many times. Some of you are tempted to just go, it's the area between 0 and 4. Don't write this down, just listen. Square root of x minus 2 dx. And immediately I have to say, nope, that's wrong. If you just write that, that's going to give you a negative answer. Can area be negative? No. Why is it negative? Well, because it's below the x-axis. But we want to make sure that we come up with a positive answer. So how do you do it? Oh, just add absolute value. Yeah, I guess you can put absolute value. Here's how you do it, guys. This curve right here, you don't see it because it's the x-axis. That curve is just y equals 0. Up minus top minus bottom. So 0 minus the square root of x minus 2. See? And then you can distribute the negative there. Negative square root of x plus 2. There it is. So if I do an integral between 0 and 4, and I integrate negative square root of x plus 2, this will 100% give you a positive answer. I don't know what that number is. It's some number. And we could do it if we wanted to, but it doesn't ask us to. Does that make sense, guys? Okay. Now let's do it with respect to y. If I do it with respect to y, so let's see. These are all dy's now. dy, dy, dy. So here's where I'm starting at. So integral, -2. And where am I stopping? Does everyone agree with this, with my limits? Okay. So if you wanted to know, that line is x equals 0, the y-axis. And then this curve here, we said was y equals the square root of x minus 2. I need it in terms of y, not in terms of x. So I'm going to move the 2. So y plus 2 equals the square root of x. And then I'm squaring it. Square, square. X equals y plus 2 with a square on it. Leave it alone. If you want to expand it and write y squared plus 4y plus 4, that's fine, but I would leave it alone. All right, here we go. Y plus 2 squared dy. Done. Well, you can, but what's y plus 2 squared minus 0? You know what I mean? You can. The question that Godinez asked is, do you have to take that 0 into account? You can write minus 0. If they would have cut it short like at 1, then you would have written minus 1. But because we're right on the axis, it's just minus 0 and you're done. How do we feel, guys? Awesome. If you type this one in the calculator and you type this one in the calculator, I think the calculator will have an easier time with the parabola than the square root, but they should be the same number to at least the first 3 digits if you want to try it out really quick before you start. So there it is. Do we feel better now today, guys? All right, so let me come back.